Hi everybody, I'm going to do a quick sample problem using our second equation for changing velocity that we got from our ramp lab, our quadratic relationship between distance and time, or d equals 0.5 at squared. And first I wanted to show you that even though this equation looks a little more complicated than the other two formulas we've worked with, you can still do a proportion circle method with it. So we have distance in the top, and then our 1/2, or if it helps you, you can change that to 0.5 acceleration times time squared, and the units are there. And you use this proportion circle in the exact same way that you do the others. So today's warm-up, to give a shot using this formula, I'm going to go ahead and work that one for you for an example, and then another one that takes a little more rearranging to show some of the complexity of this moving forward and make sure that you've got a good handle on it. So for our first example, a car accelerates at 8 meters per second per second. Don't forget to underline and label as you go when you read your problem. And it accelerates for 5 seconds. And it's asking how far does it go in this time. So remember your knowns and unknowns. And to list those, the 8 meters per second is an acceleration A. 5 seconds is our time T. And how far is distance, and that is our question mark. So to use the proportion circle, we write down our unknown D equals, cover it up, and the rest are side by side, so we multiply 0.5 times A times T squared. And this actually is just like our original formula. It did not require any rearranging. So now I'm going to put my numbers in and substitute. 0.5 times 8 is our acceleration, times our time squared. Now here's an important notice about the squared portion. You need to make sure and do that first in your calculator, because there's some weird things with order of things, especially on a phone calculator. The way we write it isn't always the way we type it in, and it depends on the calculator. So I recommend doing 5 squared first. And if you do that, 5 times 5, it's 25. And bring down the 8 and the 0.5. And now you can just multiply and multiply again. And what you should end up getting, and I'm going to turn to my calculator really quickly to do this. 0.5 times 8 times 25 is 100. It's a distance, so I look up to make sure I put my units with my answer, and I box my answer. Done. So that's not too bad. I'm going to move this up a little bit. Let's look at our second example. I'm going to make sure we can still see our formula, the proportion circle. So our second question, or sample, how long does it take a car to accelerate at 6 meters per second when it travels a distance of 80 meters? So how long is what it's asking. The acceleration is 6 meters per second, and the distance of 80 meters is given. I'm going to write those and match the letters. Distance equals 80 meters. A acceleration is our 6 meters per second. How long is the time? It wants to know the time. Now, here's a tricky thing. I don't have time alone, but I have time squared in my proportion circle. So using that, I can cover that up. I can write time squared equals, cover it up, and it's D divided by 0.5 times A. So I write D over 0.5 A. And now I'm ready to substitute my numbers in. So I have 80 for D divided by 0.5 times 6. Now I'm going to do the bottom first, again, order of operations, and just do this in a couple of steps in my calculator to avoid mistakes. 0.5 times 6 in my calculator, in my head, it's half of 6, is 3. Then I can type in 80 divided by 3 into my calculator, and I get 26.6 26.7 if you want to round, 26.6667. I'm not done yet because I haven't finished getting just the time alone by itself. I need to do one more step. Time is the square root of time squared. That's how we undo the square. We do the reverse by doing a square root. So it's a weird step, but it's necessary to figure out how long in seconds. So I'm going to do the square root of 26.7. In my calculator is my last step. And I get 5.2 seconds. Now I have my answer. So this square root step only happens in problems with d equals 0.5 at squared where you have to solve for the time itself. Makes it a little more complicated, but definitely doable. You just can't forget that last step, and your answer will be in seconds if you do it this way. All right, so let's do some problem solving practice, and I will catch up with you guys a little bit later.